I want to talk about numbers. Does this fit in
Oh
the
yeah, you got
screen?
your mathematician hat on now, or your wizard hat. I can't
Yeah.
decide.
Yeah. So I got this from, oh man, he writes too great stuff. First name Mosh, last name Zadka? Zadka? Mosh, you got to contact me and find out, tell me how to pronounce your name. But numbers in Python, really great article. I just sort of think about, in Python, you don't really have to think about numbers too much. They just sort of
Yeah.
work. Uh, but you do kind of need to think about them. And this article is a really good, quick tutorial about the different things that you need to know. Like integers, they turn into floats really easily. Like anytime there's a division, it'll turn into a float.
Right, which is
So
unlike other languages, which are like truncating sort of things, right? That basically take
or
the
like
floor of whatever the result would be.
yeah, in earlier Python versions, is 2.7
Yeah,
like
yeah,
that like truncated it
right.
off.
If you
But
want that old time, now you got a double divide, like the two slashes.
yeah, oh yeah. So and I forget about the two
Yeah, I
slashes
never use
thing.
the two
So
slashes because that seems wrong.
um uh anyway, so like the implications are weird though. And the other thing, okay, so you got integers, they turn into floats if you divide them. You got floats, which are things with decimal points in them. They're not the only things with decimal points in them though. They the one of the things you learn early on in programming, but some people are new to programming or numbers, so it's a good thing to remember, is floats don't behave like floating point numbers in math. Like the subtraction and addition are not inverses, and addition is not associative always, and you can't multiply and then divide and get the same number. Um, those are weird things you should be aware of. The normal thing that I mostly need to remember is don't try to compare floating point numbers with the double equals. You have to use something
I
like
think that's the one
approximate
that can
or something.
really, yeah, that's the one that can really catch people out. I mean, okay, so I thought I was going to get 14 and I got 13.99999999997 Okay, well, it's computers. We know that stuff's truncated, but it's really easy to go if x equals some number I'm looking for, and that never ever happens, right?
Yeah.
It's it looks right, and it is so wrong. And I think just our training for so many years in theoretical mathematics means that it's hard to look at that and go, "That's wrong."
Yeah, well, and it's interesting that if when you see it in numbers, you can like for instance, one of the examples is 1 plus 2 minus 1 is 0.
Of course, it is.
Obviously, it not if it's floating point numbers though. So floats don't end up with 0. You end up with a very small number, but it's not 0. So okay, so floats are weird. Be careful. Fractions. So if you don't use floats, there's fractions. Python has built-in fractions. I actually have never really used
I've
these.
never
It's
used them
neat. They're
either,
there.
but
They're
yeah,
there.
there's like a class called fraction with a numerator and a denominator, or it takes another fraction or a floating point, even takes a string.
Yes.
How about that?
So the warning in this article is fractions take a lot longer than you expect they would for algorithms. So you can represent things as fractions. It's cool that you can do that. Be very careful with any sort of algorithm because the it can explode in memory and size and time and stuff like that. So
That doesn't surprise
probably
me
use
because when
floating
I have
point.
to do like fraction algorithms, in my mind, it takes a lot longer too. So
Yeah, yeah. The last one that is he talks about, and it's something that some people don't realize right away, is that decimals are built in. So there's a decimals library that the and it's not probably not surprising. One of the reasons it's in there is for financial transactions. Um, so they are they're set up to be correct with precision and do the right thing. And so I'm really glad it's there. Otherwise, we'd have like competing decimal um, third party libraries or something like that. And we probably do, but this one's built in. I'm glad the article was written though because the something weird about decimals that I didn't know about was there's a global state variable that called context that holds the precision that's being used for decimal like division and stuff. And that it could be anywhere in your program that the precision gets changed. So the recommendation in this article is to use a local context. So you can do one of those blocks, context. What are those things called?
Context manager.
What those are. Context manager. Yep. You can use the context manager local context to set a local context precision for your arithmetic. So that's good.
That seems like that should be the required way, because just setting it globally seems really, I don't know, it seems wrong, because, think of the race condition there. I was doing math and then the precision got cut in half and then it wasn't what I expected anymore.
Yeah.
Or I don't know, maybe there should be a minimum precision. This is interesting though. Like, I didn't realize that you could even change the precision of decimals. So like in the docs, it says, unlike hardware-based binary floating point numbers, the decimal module has a user-alterable precision defaulting to 28 places, which can be as large as needed for a given problem. So yeah, you can change it. The example in the Python document on the docs show just globally changing it halfway through a calculation, which seems like a bad, let's kick them down the stairs instead of teaching them to hold on to the hand railing. But this is really cool. Like this local context, change it. You can set it really high. Yeah, it's cool. I had no idea that you could actually change that to grow as you needed them, which is cool.
Yeah, I guess you could still use the global context as long as you. Maybe this isn't safe, but as long as you always remember to set it before you do decimal arithmetic.
It's safe as long as you're not doing threading.
Oh yeah. Okay.
Yeah, because what if some other thread has the same idea and changes it? I think the idea is maybe, it seems to me like possibly it would be better if once set, it couldn't be set again. Like you could set it at the beginning of your program, but it couldn't be altered and altered and altered. Right? Something along those lines, like, okay, we set it, we're done. It's an exception if you try to set it again to something else and so on. I don't know.
I mean,
this is a whole world I haven't.
This
is a whole world I didn't even know about. This is cool.
Yeah, I would probably set up some sort of like hook or something to make sure that you're only setting it in one place if you're doing that. I don't know.
Sounds good to me.
Anyway.
Cool. Anyway, yeah, this is actually more interesting than I thought because, as usual, I've learned something which is cool.
Yeah, so one of the last thing on this, we're going to link to the standard library documentation for fractions and decimals because you may not have heard of them. And then a very old article that if you really care about floating point numbers, you should at least know this article exists. Although I don't think I've actually gotten through the whole thing ever. But it's what every computer scientist should know about floating point arithmetic. It's a good article.
Yeah, cool.
So,
thank you for watching this segment of the Python Bytes podcast. This video was made during the recording of the full episode. Visit pythonbytes.fm and get the whole story. Subscribe to the podcast and get the entire episode delivered to your phone. Please support our work by taking one of the courses at pythonbytes.fm/courses or learning PyTest with Brian's book at pythonbytes.fm/PyTest. Finally, visit our sponsor shown on the screen here. Visit the link on the screen and get the special offer for Python Bytes and YouTube listeners. Thanks, and have a great rest of your day.